Imagine everything electronic in your life shutting down simultaneously. Your phone, internet, electricity, banking, and transportation systems, all gone. Not for hours or days, but potentially for months or years. This digital paralysis would sever modern civilization like cutting the central nervous system of our society. And it's far from hypothetical. Such devastation mirrors the aftermath of a solar storm like the Carrington Event of 1859. Back then, telegraph operators watched in astonishment as their equipment sparked and caught fire. The crucial difference? In that era, life continued without electronics. Today, our technological dependence has created an unprecedented vulnerability that few truly understand. The Carrington Event, a warning from 1859. What if the most dangerous threat to modern civilization already happened, and we weren't paying attention? In the fall of 1859, amateur astronomer Richard Carrington was conducting his regular observation of the sun from his private observatory in England when he witnessed something extraordinary. On September 1st, Carrington observed what appeared to be two intensely bright patches of light erupting from a cluster of sunspots. Within minutes, these brilliant flashes intensified and then faded away. What Carrington had unknowingly documented was the first recorded observation of a solar flare in human history, a precursor to the most powerful geomagnetic storm ever recorded. Carrington couldn't have known at the time, but he had just witnessed the beginning of an event that would send electrically charged particles hurtling toward Earth at nearly the speed of light, followed by a massive cloud of magnetized plasma. Approximately 17 hours later, a remarkably short transit time compared to typical solar storms. This ejection slammed into Earth's magnetosphere with devastating force. The effects were immediate and spectacular. Telegraph systems across Europe and North America failed as electrical currents surged through the wires. Operators reported receiving powerful electric shocks when touching their equipment. In Washington, D.C. and Philadelphia, telegraph papers spontaneously caught fire. Some telegraph systems continued to send and receive messages even after being disconnected from their power supplies, as the induced current from the storm were strong enough to operate the equipment independently. Modern scientific analysis has revealed the true magnitude of what's now called the Carrington Event. By examining ice core samples from Greenland and Antarctica, scientists have detected nitrate spikes consistent with powerful solar storms, with the 1859 event standing out as particularly intense. The storm's magnetic field component was estimated to have changed at a rate of about 1,800 nanoteslas per minute, a measurement that alarms electrical engineers and space weather scientists. The most visually stunning consequence was the aurora display. The northern lights, typically confined to polar regions, were suddenly visible across much of the globe. The New York Times reported that many persons in this city were doubtless startled last night by the rare spectacle of a rosy light, which at about 7 o'clock shot up from the northern horizon and illuminated the heavens. From Havana, Frederick Jerstecker wrote, "The whole northern heavens were one fiery glow, as though there were a gigantic conflagration at the outskirts of the city. People in Cuba, Jamaica, El Salvador, and Hawaii looked up in awe at crimson and emerald curtains of light dancing across the night sky. Gold miners in the Rocky Mountains were so bewildered by the brightness that they awoke at 1 a.m. and began preparing breakfast, believing the sun was rising. In Boston, the light was bright enough to read a newspaper by. While the 1859 event caused fascination and some disruption, its impact was relatively minimal. The telegraph was the only technology vulnerable to the electromagnetic disturbance, and the inconvenience lasted only a few days. Life in the mid-19th century simply wasn't dependent on electrical systems or electronic communications. The event became a curious historical footnote, preserved primarily in scientific journals and newspaper archives. For context, a much smaller geomagnetic storm in March 1989 caused the collapse of Quebec's entire power grid in just 90 seconds, leaving 6 million people without electricity for 9 hours and causing $2 billion in damages in today's currency. The Carrington Event is estimated to have been approximately 10 times more powerful than this 1989 storm. Perhaps most alarming is how close we've come to experiencing another Carrington-level event in recent times. In July 2012, NASA's Stereo-A spacecraft detected and measured a coronal mass ejection of comparable intensity to the 1859 storm. The only reason we avoided catastrophe was trajectory. The 2012 eruption missed Earth's orbit by just 1 week. Had it occurred a mere 7 days earlier, we would have found ourselves in the direct path of a Carrington-level event with our modern, vulnerable infrastructure. In 2014, physicist Pete Riley published a sobering analysis in Space Weather Journal, calculating a 12% probability of Earth being hit by a Carrington-level event in the next decade. That's roughly a 1 in 8 chance of facing what would undoubtedly be the most significant technological disaster in modern history. What made the Carrington event so powerful was a perfect storm of factors. The sheer magnitude of the coronal mass ejection, its remarkable speed, its southward-oriented magnetic field, particularly effective at interfering with Earth's own magnetic field, and multiple CMEs in quick succession, with later ejections traveling through the path cleared by earlier ones. If the Carrington event were to repeat tomorrow, the consequences would be drastically different from those in 1859. High-voltage power transformers would be overwhelmed by induced currents, potentially igniting fires and melting critical components. These custom-built transformers typically take 12 to 18 months to replace. Satellites would be damaged or disabled. GPS systems would fail. Internet infrastructure would suffer widespread outages. Electronic payment systems would collapse. And all of this would happen simultaneously across large portions of the globe. As we'll explore next, our modern civilization has unwittingly constructed the perfect conductor for a solar storm disaster, creating vulnerability on a scale our ancestors could never have imagined. Our